And you think, okay, do I just keep all of those digits in all of those place values, or where do I round it off? Significant figures tells you where you round it off when you get one of those numbers that just kind of, spits out, your calculator spits out a whole bunch of decimal places. Not decimal places, numbers after the decimal place. So let me give you the rules for significant figures, and then we'll do some examples. Significant figures. Okay, these are also referred to as Sig Figs. And we will get to say that term a lot together this year, Sig Figs. Have you used them before? I hope so. And if you haven't, then it's a great time to learn right now. Okay, a digit within a number, here are the rules. A digit within a number is a Sig Fig if, number one, it is non-zero. A digit within a number is a Sig Fig if it is non-zero, or two, it is a zero between two Sig Figs. Or, third and final, it is a zero. It is a zero at the end of the number, and to the right, okay, number three is, it is a zero at the end of the number and to the right of the decimal place. Those are the digits that are considered significant figures. Okay, let's take a look at example 5. First, let me write in here one more thing about significant figures. So, significant figures help because if two instruments measure the same thing, the one to give a Sig Fig, in the smallest decimal place, is more precise. Hi, Sam.
Hey, can I go to Davin's?
No.
Okay.
Okay, if two instruments measure the same thing, the one to give a Sig Fig in the smallest decimal place is more precise. For example, if one scale reads 200 pounds, another scale reads 200.1 pounds, okay? This scale is more precise, isn't it? Because it gives the smallest decimal place. It goes to the 10th of a pound. Another example, 5 pounds is shown on one scale versus 5.0 pounds, okay? This 0 right here is significant. It is to the right of the decimal point, and it is at the end of the number. So here we have two significant figures. Here we only have one significant figure. this scale would be more precise because it would show you a smaller decimal place. Let's do an example, example 5 on page 21. Count the significant figures in each of the following numbers. I'm going to move up to the top one last time, I hope. So you need to memorize those significant figure rules, okay? Because it makes a difference when you are doing calculations on your calculators or phones. If you put in 3.2107 times 6, you're going to end up with a different number than if you just did 3.2 times 6. Sometimes, you know, numbers will get rounded up and it'll make a difference in the final calculation, and then you'll get it wrong. Uh-oh, here comes Natalie. We're going to try to quick get this done. Okay, example 1.5.
Mommy,
Yes, dear.
I want some chicken, so can't you bring me it down?
Yes, she wants some chicken. Sammy, will you bring her some chicken downstairs, please?
Mm-hmm.
Thank you. A, 3.234. How many significant figures are here? Oh no, my rules are gone. Hopefully I have committed them to memory. It's okay, Natalie. She looks really concerned right now. How many significant figures are here? Okay, the first rule was that a digit is a significant figure if it is non-zero. So we have 1, 2, 3, 4 digits here that are non-zero. So the answer is 4. B, 6.016. Okay, let's count up the significant figures. First, let's start with the digits that are not zero. This one, this one, this one. What about this 0 right here? Well, based on the second rule, a digit is a significant figure if it is a 0 in between two significant figures, which means that one is significant also. So this is 4. C, 105.340. How many significant figures here? These are the ones that are non-zeros. 1, 2, 3, 4 of them. This 0 is in between two significant figures, so it is significant. This 0 follows rule number 3. It's at the end of the number, and it's to the right of the decimal place, so it is also significant. So this number has 6 significant figures. And one more, D. Oh my, 0.00. 0.00450010. How many significant figures here? Okay, let's start with the ones that are not 0, the 4, the 5, the 1. How about these zeros out front here? Are they between two significant figures? No, they're not. And they're not at the end of the number either. So these are not significant. How about these two? They are in between, just because there's 2 of them, they're still in between two significant figures, so these are significant. How about this one over here at the end? It's not between significant figures, but it is at the end of the number, and it is to the right of the decimal place, so it is significant. So notice that this 0 out front here, to the left of the decimal place, you might think that's important. It might be important, but we don't call it a significant figure. So this one has 6 significant figures. All right. 2 more rules about adding and subtracting and then multiplying and dividing with significant figures, and then we are done with the first half of Module 1. Adding and subtracting Sig Figs. Adding and subtracting Sig Figs. You round the answer to, so it has the same precision. Round the answer so it has the same precision as the least precise Sam, don't do that. Okay, I really don't want to have to give all these notes again. Measurement is the last word there. So when adding and subtracting significant figures, you round your answer so it has the same precision as the least precise measurement. Okay, so if we're doing 3.21 plus 6.7, our answer is only going to be as precise as the number with the least precision, which is 6.7. 6.7 goes to the 10th. This one goes to the 100th. This is less precise. So our answer can only be to the 10th. So this 1 really doesn't make a difference. We can bring it down, and then 9 and 9. But we're gonna round to this place value. So the answer, you would only write down as 9.9, okay? And then one more rule, multiplying and dividing. Okay, multiplying and dividing sig figs, round the answer so it has the same number of sig figs as the measurement round your answer so it has the same number of sig figs as the measurement with the fewest sig figs. Okay, so if we have 3.21 times 1.1, 3.21 has 3 significant figures, 1.1 has 2 significant figures, so our answer can only have 2 significant figures. Okay, so whatever our answer would turn out to be, I'm not going to do it right now, but you would have to round it so that you only have 2 significant figures. All right, and I will let you look at the examples in your book for more examples of those, because I think we've had enough time together today. Even though I've thoroughly enjoyed myself, it's time to make sure that my children are still alive. As you're going through this module, you can kind of cut it in half like I did today. I just did the first half of the module, and I will post another video a little bit later for the second half of the module. Okay? Please remember to text me or email me if you don't understand something, either from my notes or from the textbook or the homework. Please let me know ahead of time. Okay? I hope that you've enjoyed this.